The universe is full of countless wonders and mysteries. In them, NASA found regions where nothing seems to exist, vast empty spaces without matter called cosmic voids. These vast voids are remarkable not only for their size, but also for their enigmatic nature, which challenges our understanding of the cosmos. For more than 3 decades, scientists have been trying to understand these strange regions, where matter does not seem to exist. These voids contrast greatly with the rest of the universe, where galaxies and stars abound. They seem to defy the known laws of physics, suggesting a possible new phenomenon in the structure of spacetime. The size of these voids, millions of light-years across, presents a significant challenge to traditional cosmology in Einstein's theory of relativity. One of the most prominent examples is the Boötes gap, discovered by the astronomer Robert Kirshner and his team in 1981. This void contains about 330 million light-years and is almost completely devoid of visible matter. Originally thought to be a unique anomaly, we now know that there are many such voids, some even larger, such as Eridanus and the northern local void, which span over 500 million light-years. These slots are not completely empty, they contain isolated galaxies that resemble lonely islands in an ocean of darkness. The presence of these galaxies in the void makes these regions even more fascinating and terrifying. The formation and distribution of these vast voids can provide insights into dark matter and dark energy, the mysterious forces thought to be responsible for the accelerated expansion of the universe. To understand voids, scientists hope to learn more about the effects of gravity in regions with little visible matter. Observations of light from objects beyond these voids can reveal how gravity works at great distances, shedding light on the distribution and properties of dark matter. Studying the geometry and dynamics of cavities can also provide clues about the nature of dark energy. Imagine if our galaxy was in one of those voids. Early astronomers like Edwin Hubble, who first discovered our galaxies in the 1920s, would have seen nothing but darkness. It would have taken decades longer to detect the nearest galaxy. Our view of the universe would be dramatically different because we believe it is sparsely populated. This thought experiment highlights how our current understanding of the universe has shaped our particular perspective. The discovery of the cosmic void reminds us that what we think is normal may be the exception elsewhere in the cosmos. Exploration of these voids continues to push the boundaries of our knowledge, revealing the complex and mysterious nature of the universe. The universe is home to many unusual wonders and strange places. NASA has discovered regions so empty of matter that it is truly terrifying. Questions arise, such as why matter disappeared from these places or how these vast areas evolved. For more than 30 years, scientists have been puzzled by these voids, but recent discoveries have provided fascinating and disturbing insights. Analysts discovered vast starless deserts where the light of millions of galaxies and infinite stars would normally shine. Instead, there is only darkness and emptiness. These strange spacetime anomalies stand out in a unique way from the rest of the cosmic environment and seem to defy the known laws of physics, perhaps representing a new phenomenon. These vast empty regions contradict Einstein's equations of relativity and challenge the notion of unified cosmic structures. Their size, reaching millions of light-years, exceeds the largest known galaxy areas. A beam of light traveling at nearly 300,000 km per second would take thousands of years to cross these vast voids, even larger than the Virgo cluster or the Laniakea supercluster. Despite the scarcity of matter, these areas are not completely empty. Scientists have found isolated galaxies in these voids, making the void even more terrifying. These cosmic voids could change our understanding of the universe and its structure. They may be the result of natural cosmological processes or relate to phenomena that we do not yet fully understand. One of the most prominent examples of these structures is the Boötes gap, discovered by the astronomer Robert Kirshner in 1981. This void spans around 330 million light-years and is devoid of matter. Originally thought to be unique, it is now known that there are many such voids, some even larger, such as the Eridanus void and the North Local void. Together, these voids make up a significant part of the universe. When talking about the void of the universe, terms like dark matter and dark energy come to mind. Some theories suggest that the size and distribution of voids may provide insight into the nature of dark energy, which is believed to be responsible for the accelerated expansion of the universe. Despite the absence of visible matter, these voids can contain invisible forms of matter such as dark matter. Vacuum studies allow cosmologists to study gravitational effects in an environment that does not contain large amounts of visible matter. By studying the light from objects behind these voids, scientists can learn about the gravitational forces at play and the distribution of dark matter within them. If our galaxy existed in a vacuum, early astronomers like Edwin Hubble might never have discovered other galaxies. Only the technological advances of the 1960s allowed us to observe distant galaxies. The voids remind us that our understanding of the universe is still limited, and what we consider normal may be the exception elsewhere. Ultimately, these vast empty regions challenge our view of the universe and suggest that our perspective may be biased. What we consider normal may be the exception in other parts of the cosmos.